Hi everyone, my name is Tülay Soylu and I am from George Mason University. Today in this short video I will share with you how using different algorithms will lead us to having the same network. So the agenda will be, first I will define what Bayesian networks is, and then I will emphasize the importance of using sequence data in analysis. And I will show you step by step how it is applied in R and conclude with my findings. Bayesian networks are graphical models, and as it is shown on the small graph below, nodes represent random variables and arrows represent probabilistic dependencies. During my analysis, I will use three constraint-based algorithms. The first one is growth shrink. The second one is called IAMB, and the Heaton sequence. Before we move on, I would like to give you an example. This is an example of sequence of diagnosis for a cross-sectional study. So as you see on the left, time is shown as months, and at the bottom you see all the diagnosis and data was entered by the time of incidence that it happened, starting with the cannabis, social phobia, all the way to the end, liver, heart disease, vascular disease. Sequence can be discovered, yes, however, it is most of the time ignored. At the end of this analysis, you will understand how important using sequence data is. So in this small example, you see the demographics. Demographics cover like sex, race, ethnicity, age, education, things like that. And we already know from the definition of this example that demographics comes first and then the medical history comes second. So this is basically an example of a time sequence data again. In this analysis, I will be using simulated bundled data set. I have 13 variables, and this data has 130,000 observations. Now we are moving on the application side. I'm assuming that you have R in your computer. If you do not have it, please pause it here and go ahead and install the free version of R. It's easy to install. I will also share with you these steps one by one, but we will be basically going into a website that everything is provided for us. So you type in the Explorer openonlinecourses.com, and we will choose comparative effectiveness, counterfactual framework, and we will choose the network analysis using growth shrink, Heaton, and sequence R codes. So we'll do this one by one, no worries. Okay, so I'm assuming that you typed in openonlinecourses.com. You will be directed to this page that you see on the screen. So you click on the comparative effectiveness. Then you click on the highlighted red on the arrow on the right above, counterfactual framework. Then you will be led to again another page. Then you will choose number 6, network analysis using growth shrink, Heaton, sequence R code. Okay, so we are almost there. When you click on this page, you will be given all these codes. Thanks to my colleague at George Mason University, Department of Health Administration and Policy, they provided all the codes for us to make it easy. So you first install packages beyond learn. You just basically copy this install packages beyond learn and library beyond learn on your R space. You will be given this outcome. As you can see on the screen, it shows library BM Learn. So it shows that it's already installed on your R workspace. Okay, now it is time to load our data. Wherever the data is, go ahead and use File, Load Workspace, and choose your file. And then it will be on your R workspace. Then again, going back to the same website that I showed you earlier, you copy paste this part starting with the D equal read CSV. We want to read our data. And then copy paste it to your R screen. Then we will be doing a small trick. Fix D, typing fix D, we will see our data on the next here. Okay, see how we read our data with the red, D red at the bottom on the left, and then I just typed in fix D. It will automatically show me my data. So I know that my data is there. Now I can move on with the analysis of 3 constraint-based algorithms. Okay, before we do the analysis with 3 constraint-based algorithms, on the same website, you will be basically copying all these long function. In case something happens to the website, I copied everything here. So you can get the long function from here. It is 3 pages. I will just skip. Okay, I'm assuming that you copy pasted this long function. Now we are starting with the sequence growth shrink first algorithm methods that we will be doing analysis. As soon as you copy paste this I equal GSSS command for growth shrink, it will ask you your data points, CL1, DME1, P1. So you already know your data points, sequence data points, so you just basically type in. At the end, when you enter, give you your diagram. So this is our output for growth shrink method. We are moving to the second method, which is called IAMB sequence. The same thing again. You enter your data points, and at the end, when you enter, it will give you your diagram for IAMB. And the final algorithms is called HITON. The same thing, you just copy paste your command, CI equal HITON sequence from the same website that I showed you earlier. Enter your data points. At the end of N, you will get diagram. Okay, so we run 3 different constraint-based algorithms with sequence data. What's our conclusion? I highly suggest you to now go back and compare these 3 outcomes. So you will see that using 3 different algorithms will lead us to same network, the same setup of the nodes and the same errors among each of these nodes. So as a conclusion again, even though we use 3 different constraint-based algorithms, we got same network. This shows us that using sequence data is very important. I wish you a great day. If you have any comments or additions or any view, so please post it here on this YouTube, under the YouTube video. Have a great day. Bye.